So it says the two other properties that come in handy, we use it more for equation solving than we do anything else. Log base b of b is 1, and this is related to the idea that b to the 1 equals b. And log base b of 1 is 0, and property of exponents is this guy, b to the 0 equals 1. And we're going to be using this guy right here in these next problems. It says, suppose I want to find, without a calculator, the log of 10 cubed. Well, the log of 10, this log is base 10. Using the properties of logarithms, I can bring the 3 down in front. So this is 3 log base 10 of 10. And this is property 2. What's log base 10 of 10? You go up here, log base b of b is 1. If the base and the argument are the same, you end up with 1. So this guy, base 10 of 10 is 1, which is why this works. So I end up with 3 times 1, which is 3. This one's the hard one because it's log of 0.10 or 0.01. This is log base 10 again. But I need to replace that argument by something different. And 0.01 is 1/100th. Which is 1 over 10 squared. Which is equivalent to 10 to what power? -2. So that says 0.01 is the same as 10 to the -2. Don't worry, this isn't a test question. Just now enables us to play with the properties of exponents. Now, property 3 says bring the exponent down in front. So -2 log base 10 of 10. Log base 10 of 10 is 1. So I end up with -2 times 1, or -2. Now we get to play with E. And the only good thing about this is it's going to force you to start rewriting natural log in terms of its base. So you get used to the fact that natural log is base E. Because this becomes log base E, that's natural log, of e to the -4. And this we're going to run into in equation solving. Property of exponents says bring the -4 down. That's property 2. So this is -4 log base E of E. What's log base E of E? 1. Because the argument and the bases are the same, it's 1. So this becomes -4 times 1, or -4. Do you want to? Yep. Now I'm going to rewrite this guy. He is the natural log of what's 1 over e squared? E to what power? -2. Because I need log base E of E is what I need. So natural log is log base E of e to the negative 2. Then property 3 allows me, or 2 allows me to bring the exponent down, negative 2 log base e of e. Log base e of e is 1. So you have negative 2 times 1, which is negative 2. About as exciting as it gets with that stuff. The next series of problems are our first equations that we're going to solve. And you notice they're log and natural log, so they're going to be log base 10, log base e. And it says, how do you solve a logarithmic equation? Well, you write it as an exponential. So in this, I rewrite this guy, he is log base 10. So I first make sure he has a base. Then I rewrite as exponential equation. Now this is where you've got to be able to go from logarithmic to exponential notation in your sleep, because it becomes 10 to the 2 is equal to x minus 5. I have an equation I can solve for x. This says x minus 5 equals 100, because that's what 10 squared is. Add 5 to both sides, x is 105. So that says that log base 10, that log base 10 of 105 minus 5 should equal 2. This is log base 10 of 100 which is log base 10 of 10 squared. Or I'll tell you what, the easiest thing to do is put it into your calculator, which becomes 2 log base 10 of 10, which we know is 1, or 2. But I do have log base 10 on my calculator, so once I get it to log base 10 of 100, all I need to do is take the log of 100, and you'll come up with 2. Because these problems are log base 10. So it's 105, so it'll check. The big thing is rewriting as an exponential and solving for x. And I'll put this up and freeze it for those who need to put some of this stuff down here. So once we're done. This is ln of, well, we know that ln is log base e of 2x plus 4. That's equal to 3. And now I just rewrite, which says that e to the 3 is equal to the argument. So 2x plus 4 equals e cubed. Now, if you're not comfortable using e cubed, because it says do an approximate solution, give an exact solution, but with working with this stuff, if you're not comfortable with e cubed, just do a calculation. E cubed is 20.0855. Just put 20.09. And then what you would have here, if this guy was 20.09, is that you'd have an equation that was just numbers. But I'm going to leave it as e cubed, because it's just a number. So solving for x, I'm going to subtract 4 from both sides, so that 2x equals e cubed minus 4. Divide both sides by 2 to solve for x, or x equals e cubed minus 4 over 2. This is what we call an exact answer. It's an exact answer. And the reason for that is the minute I turn e cubed into a number like 20.09, I've rounded. So if I want the approximate, I would put that into my calculator. How I would do that, I'm going to move this up, so I'm going to have both at the same time here, is I'm going to take e cubed, I'm going to take the numerator, make sure I put my parentheses in, subtract 4. If I don't put parentheses in, oops, I need e, not 10. If I don't put the parentheses in, that will then make that negative 4 part of that exponent. That's the numerator. Divide that by the denominator, which is 2, and then I would round. And they say to 2 decimal places, so it's 8.04. So the approximate is 8.04. So that's the approximate answer. Now we'll need that when we're doing application problems. But otherwise we don't need it. Doesn't matter, I don't care which way you do it.